In this video, we're going to introduce factorials and permutations. So factorials are those numbers that have the exclamation mark after them. And we say that if n is a positive number, then n factorial, written n exclamation point, is just n times n minus 1 times n minus 2, all the way down until 1. So essentially, if we have, say, 3 factorial, what we're saying is that 3 factorial is equal to 3 times 2 times 1, which is just equal to 6. If we have 6 factorial, then we have 6 times 5 times 4 times 3 times 2 times 1, which is equal to 30, 120, 360, 720. If we have 0 factorial, we are defining 0 factorial to be equal to 1, and we can think of it in the sense of rearranging. There is one way to rearrange nothing. So we can also think of factorials as an example of permutations. So 3 factorial would be the number of ways to arrange 3 objects. 6 factorial is the number of ways to rearrange 6 objects. So here's that example. How many ways can we write a list of 7 numbers, so 1, 2, 3, 4, 5, 6, 7, without repeating any? Okay, so that means that for the first number we pick, we can pick any of the 7. So we have 7 choices for the first number. For the second number, let's say we pick 3 as the first number. Then for the second number, we only have 6 choices remaining. So let's say for the second number we pick 6. Then for the third choice, we only have 5 numbers remaining. So on and so forth for each subsequent spot. So if we want a list of 7 numbers without repeating any, we have 7 choices for the first slot, 6 for the second, 5 for the third, 4 for the fourth, 3 for the fifth, 2 for the sixth, and then 1 for the final slot, which is the same thing as saying 7 factorial. So ways to rewrite a list of 7 numbers without any repetitions is just 7 factorial. Okay. Now, what if the first 3 numbers in the list must be even? So let's add a condition to this. Okay, so what are the even numbers we have? Well, we have 2, 4, and 6. Okay, so for the first number in the list, we have 3 choices because we have to choose from the first 3 even numbers. So I'm assuming here that we cannot repeat any. So for the second even number, then I would have 2 choices remaining. Let's say I pick 4 in the first slot, then I could pick 6 in the second, and then for that third slot, I could only pick 2, so I'd only have 1 choice. Okay, so the first 3 numbers had to be even. Those are the ways we can fill up the first 3 slots. And then for the remaining 4 slots, well, we're left with a bunch of odd numbers. We're left with 1, 3, 5, and 7. So there's 4 choices for the 4th position, 3 choices for the 5th position, 2 choices for the 6th position, and 1 choice for the final position. So here we get an answer of 4 factorial times 3 factorial. Okay. So when we have conditions, sometimes we have to break these problems down into steps. So in the first question, we could have whatever number we want in any position. So we could have 7 choices for the first. But in the second problem, we have these first 3 positions which have to be even, and then the remaining positions can be whatever. So we did have to look at our even options first, and then we could fill in with the remainder. Okay, so when we did that, what we did was we picked from the entire list. So we took 7 items and we rearranged all 7 of them. Well, what if we want less than 7 items? So what if we have a list with n things, but we only want k of them? So for example, what if we want 7, like a list of 7 items, and we want to pick 4 from them? So it'll be the same problem as before. For the first slot, we have 7 possible choices. For the second slot, we have 6 possible choices. For the fifth slot, for the third slot, we have 5 possible choices, and for the fourth slot, we have 4 possible choices. Okay, so this is how we pick 4 numbers from a list of 7 without repeating any. Now, what's this formula at the top here? Well, this formula is the same thing as what we have written down here. So let's rewrite this problem in terms of this formula. So n is the number of elements in the list. So we have 7 items in the list, so let's replace n with 7. Okay. So we want to pick k of them. So we're going to subtract, well, we're picking 4. 4 is equal to k in this case. So this is 7 factorial over 7 minus 4 factorial. Now this is equal to 7 factorial over 3 factorial. So how are these two equivalent? Well, let's take a look at the math. What is 7 factorial over 3 factorial? If we expand this out, this is 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, 3 factorial is 3 times 2 times 1. Now, these all cancel. So what we're left with on the top is 7 times 6 times 5 times 4, which is exactly what we have on the left side. Okay? So, if we just take the formula n factorial over n minus k factorial, we can just plug in some numbers and get a result, or we can do it in the same method where we count each case and we end up with the same result. Of course, the formula is a lot faster and is essentially a derivation that we can take from all of these examples. Okay, now what if we don't use numbers? What if we try to disguise these questions as word problems? For instance, how many ways can we order the letters in the word basket? Okay, so here we have B-A-S-K-E-T. We don't have any repeating letters here. So why don't we just assign these letters numbers? Okay, 1, 2, 3, 4, 5, 6. So how many ways can we order the letters in the word basket is really the same thing as asking how many ways can we rearrange the numbers in the list 1, 2, 3, 4, 5, 6. So we know this is just going to be 6 factorial. There's 6 choices for the first slot, 5 choices for the second slot, 4 choices for the third slot, and so on. Okay, what about this? How many ways can we order the letters in the word air? Okay, so this is interesting because we have 2 letters that are the same. This is kind of like having 2 numbers that are the same. Now, there's an interesting problem here because if we were just to write all of the different combinations or permutations we could have ERR, we could have, and actually let's just label these R's explicitly. So the first R is R1 and the second R is R2. We could have ER2 and R1, so we could flip the R's. We could have R1E, R2, R1, R2E. We could also have R2E, R1, and we could have R2E, R2, R1, and E. So in total, we think we have 6 different ways to do this if we list out all the possible combinations. But what we notice is that, well, ER1R2 and ER2R1, they're really the same thing because in words, an R is an R. We also see here that R2, R1, and E are pretty much the same thing, and so is R2, ER1, and R1, ER2. So really, we don't have 6 different possible ways to do this. We have 3. Okay, so what formula can we use here? If we were just to do this regularly, we would say this is 3 factorial, because we'd have 3 different things to rearrange. But what we see is that there are some duplicates. So what we can do is we can divide by the number of times every single letter occurs. So this may sound a little interesting. So ERR, there's only one way that we can arrange our E's inside the word. So we divide by 1 factorial, and this really doesn't do anything. But with the R and the R, there's 2 different ways we can arrange the 2 R's in every single case. So we can divide by 2 factorial. So the 1 factorial doesn't do anything, so this is just 3 factorial over 2 factorial, which is 3 times 2 times 1 over 2 times 1, and we're just left with 3 as a result. Okay, let's do a more complicated process. Mississippi. Okay, so we have an M, we have an I, we have two S's, we have another I, we have another two S's, we have an I, we have two P's, and an I. As you can see, I've rearranged the letters in kind of this grid. And what I'm doing in this grid is I'm figuring out how many of each letter occurs. So I know we have one M, four I's, four S's, and two P's. If we want to rearrange this, well, how many letters are there in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if we just want to rearrange all of the letters, there's 11 factorial ways of doing this. But we have some repeat letters, which means that if we take, say, S1, S2, S3, and S4, it doesn't matter what order they're in. They're all the same. So we divide by the number of similar letters factorial. So if we have 1M, we divide by 1 factorial. If we have 4 I's, we divide by 4 factorial. 4 S's, divide by 4 factorial. 2 P's, divide by 2 factorial. And this is how many ways we can order the letters in the word Mississippi. Now, the nice thing about this method is that this works for every single case, whether there's duplicate letters or not. Let's look at the first problem with basket. Well, if we think about basket, there's 1B, 1A, 1S, 1K, 1E, and 1T. So we do 6 factorial divided by 1 factorial, 1 factorial, 1 factorial, 1 factorial, 1 factorial, and 1 factorial. So this is the same method as before, but because we only have one of each, this is just dividing by 1 6 times. So this is just 6 factorial. So you can just use this method for every problem if you wanted to. And here's one more problem where we have permutations, but it's disguised as a graphical problem. So here's the question. How many paths are there from 1, 1 to 4, 3 if we can only move right on a grid or up on a grid? So here visually, we're starting at the point 1, 1. We want to end at the point 4, 3. And we can either go up or we can go right. I'm going to give these specific labels. I'm going to say going up is called north and going right is called east. Okay, so what do we have to do to get from 1, 1 to 4, 3? Well, we need to move right a total of 3 times. So we need to give ourselves 3 east movements. And we need to go up 2 times sometime in our walk. So we need to give ourselves 2 north movements. Okay, so however we can jumble these up, we can get a path from 1, 1 to 4, 3. And we can show this on the grid. So let's actually do this example. Let's get some random sequence like N, E, E, N, E. Okay, so we start at 1, 1. So first we're going to go north. Now we're at 1, 2. We're going to go right to 2, 2, right to 3, 2, north to 3, 3, and then east to 4, 3. So that's one path. So really this is just a word rearranging problem. There's 5 total letters, essentially, 5 total moves. 3 of them are easts, so we divide by 3 factorial. 2 of those are norths, we divide by 2 factorial. And this is the number of ways in order to walk from 1, 1 to 4, 3 if you only move right or only move up. If you have any questions, please leave them in the comments below, and I'll answer them the best that I can.